How does the Earth rotate? Have you ever wondered how the Earth rotates? Every day we wake up, go to work, interact with our friends and families, and generally just go about our lives without noticing that our planet is constantly rotating. Well, in this video, we are taking a trip to space to better understand Earth's rotation. So strap on your spacesuit and start the countdown as we head to the stars to find out how and why our planet rotates. First, let's establish why the Earth spins. Earth spins because of the way it was formed. Our solar system formed about 4.6 billion years ago when a huge cloud of gas and dust started to collapse under its own gravity. As the cloud collapsed, it started to spin. Some of the material within this cloud gathered into swirling eddies and eventually formed into planets. As the planets formed, they kept this spinning motion. This is similar to what you see when skaters pull in their arms and spin faster. As material gathered in more closely to form a planet, like Earth, the material spun faster. The Earth keeps on spinning because there are no forces acting to stop it. Imagine a line passing through the center of Earth that goes through both the North Pole and the South Pole. This imaginary line is called an axis. Earth spins around its axis, just as a top spins around its spindle. This spinning movement is called Earth's rotation. At the same time that the Earth spins on its axis, it also orbits or revolves around the Sun. This movement is called revolution. A pendulum set in motion will not change its motion, and so the direction of its swinging should not change. However, Léon Foucault, a famous French physicist, observed that his pendulum did seem to change direction. Since he knew that the pendulum could not change its motion, he concluded that the Earth underneath the pendulum was moving. An observer in space will see that Earth requires 23 hours, 56 minutes, and 4 seconds to make one complete rotation on its axis. But because Earth moves around the Sun at the same time that it is rotating, the planet must turn just a little bit more to reach the same place relative to the Sun. Hence, the length of a day on Earth is actually 24 hours. At the equator, the Earth rotates at a speed of about 1,700 kilometers per hour. But at the poles, the movement speed is nearly nothing. For Earth to make one complete revolution around the Sun takes 365.24 days. This amount of time is the definition of 1 year. The gravitational pull of the Sun keeps Earth and the other planets in orbit around the star. Like the other planets, Earth's orbital path is an ellipse, so the planet is sometimes further away from the Sun than at other times. The closest Earth gets to the Sun each year is at perihelion, 147 million kilometers, on about January 3rd, and the furthest is at aphelion, 152 million kilometers, on July 4th. Earth's elliptical orbit has nothing to do with Earth's seasons. During one revolution around the Sun, Earth travels at an average distance of about 150 million kilometers. Earth revolves around the Sun at an average speed of about 27 kilometers or 17 miles per second. But the speed is not constant. The planet moves slower when it is at aphelion and faster when it is at perihelion. The reason the Earth, or any planet, has seasons is that Earth is tilted 23.5 degrees on its axis. During the northern hemisphere summer, the North Pole points toward the Sun, and in the northern hemisphere winter, the North Pole is tilted away from the Sun. With all these rotations and revolutions, you are probably wondering, why don't I feel the Earth move? The answer is quite simple. Earth moves very fast. It spins or rotates at a speed of about 1,000 miles per hour, and orbits around the Sun at a speed of about 67,000 miles per hour. We do not feel any of this motion because these speeds are constant. The spinning and orbital speeds of Earth stay the same, so we do not feel any acceleration or deceleration. You can only feel motion if your speed changes. For example, if you are in a car which is moving at a constant speed on a smooth surface, you will not feel much motion. However, when the car accelerates or when the brakes are applied, you do feel motion. So basically, we are used to the speed and spinning of the Earth, so we don't notice it. Another aspect of Earth's rotation we need to mention is how it has slowed over time. Over millions of years, Earth's rotation has been slowed significantly by tidal acceleration through gravitational interactions with the Moon. This gradual rotational deceleration is empirically documented by estimates of day lengths. These measurements found that the length of the day has increased steadily from about 21 hours to the current 24 hours. The current rate of tidal deceleration is anomalously high, implying Earth's rotational velocity must have decreased more slowly in the past. Empirical data tentatively shows a sharp increase in rotational deceleration about 600 million years ago. Some recent large-scale events, such as the 2004 Indian Ocean earthquake, have caused the length of a day to shorten by 3 microseconds by reducing Earth's moment of inertia. Post-glacial rebound, which is the rise of land masses after the removal of the huge weight of ice sheets during the last glacial period, is also changing the distribution of Earth's mass, thus affecting the moment of inertia of Earth and Earth's rotation period. The length of the day can also be influenced by man-made structures. For example, NASA scientists calculated that the water stored in the Three Gorges Dam has increased the length of Earth's day by 0.06 microseconds due to the shift in mass. So now, let's go over what we've discussed in this video. When our solar system formed out of a gas cloud called a nebula, there was lots of dust and gas coming together due to the force of gravity. The dust and gas was already moving around in a circle. As it all clumped together to form the Sun and the planets, these new objects started to spin, and then spin faster. When you make a spinning object more compact, it spins faster. It's just like how an ice skater or a ballerina brings in his or her arms when they want to spin faster. So when all of the rocks in the clump of dust and gas started coming together, that made the Earth's spin speed up. So we've covered what made the Earth start spinning and what made it pick up speed and lose speed. But how does it keep spinning? Imagine a spinning top. You added energy to it by starting the spin off with your hand. Eventually it stops because the ground it is spinning on is taking energy away from the toy top through something called friction. Friction is where something rubs on or drags on an object and takes energy away. Have you ever slowed yourself down while you're riding downhill by dragging your foot on the ground? That's friction. There's not much friction in a fidget spinner toy. That's why they can spin for so long. Now imagine the Earth floating in space. It will keep spinning unless something slows it down. It would take a lot of energy to slow down the spinning Earth because it is so big. It's not spinning on the ground, so the ground won't slow it down. There's no air outside our own atmosphere to slow it down either. That is why the Earth has continued to spin for a very long time. But some things are slowing the Earth down or could change its spinning in the future. The Moon causes the waves and tides in our oceans. Because of this, the Earth is slowing down very slowly, about 1 second every 50,000 years. As a result, the Moon is also slowly moving away from us. When the Earth and Moon were very new, the Moon was much closer. In fact, it is thought that the Moon was once part of Earth, but they came apart during an explosive collision with a huge asteroid. Scientists examining rocks realized that there used to be many more days in a year. In the age of the dinosaurs, a day was 22 hours rather than the 24 hours that it is today. The sun's gravitation also causes the Earth to slow down a bit too. And if an asteroid or comet hit the Earth, that might speed us up, slow us down, or even knock us over. Scientists think that this may be what happened to Uranus, which is actually on its side. You can tell by the vertical stripes the clouds make rather than the horizontal ones you see on Earth, Jupiter, and Saturn. So as you see, the Earth was already rotating the moment it was created, and after years of tidal deceleration and other events, our planet's rotation slowed. The Earth spins on an axis and takes 24 hours for it to do a complete rotation. As it spins, it also revolves around the Sun, and a full revolution takes 365 days, or a full year. It's safe to say that the rotation and movement of our planet is very important as our days, weeks, and months revolve around them. If you want to check out more Earth-related videos, make sure to watch the recommended video on your screen and make sure to subscribe. If you want to suggest a topic, head over to www.howdoes.net. Thanks for watching, and we will see you next time.